Hello and welcome to Mr. Barton's autograph video number 48. Now this week we continue our look at the wonderful world of integration and we move it into the land of three dimensions by taking our first look at how autograph can handle volumes of revolution. Now this is going to be an introduction video and then we're going to look at more complicated ones next week. Right, so let's get our page set up first because this is takes a bit of time. First thing, we're going to need a bit of 3D, so new 3D graph page. Now I'm a big fan of the black background, but I tend to find that it's a little tricky to see on the interactive whiteboard, so I'm going to move to this medium background, which works quite well. And I'm also going to just right click and get rid of the key at the bottom. Now, as we've talked about with 3D before, I'm not a big fan of having these X, Y's and Z's on the outside. So let's sort that out first. So I'm going to go to my edit axes and I'm just going to go to, I think it's options. And I'm going to remove the tick of the always outside. And I'm also going to get rid of the bounding box and click OK. Now, before you draw anything 3D in autograph, it's a good idea to see what the students make of it. So I'm going to challenge the students to think what on earth the equation y equals x squared, just hit x twice, plus 2 would look like when plotted in 3D. And this goes back to when we were chatting about equations of planes weeks and weeks and weeks ago. As soon as you bring in a third axis, it changes the whole thing. So once students have had a chance to think what the shape's going to be like and how it's going to differ in 3D, let's have a look at it. And there it goes there. Now remember to drag things around, all I'm doing is holding down my left mouse button and just dragging things, and there's your lovely little curve. Now, when we're doing volumes of revolution, we need to kind of stop thinking about this z-axis because it's going to mess things up. So what I'm going to do is actually going to plot that in 2D. So if you just give that a little double click, you'll notice this little option, plot as a 2D equation. So I'm going to do that and click OK, and that's looking a bit more like it. And better still, if you just hover up here, instead of having XYZ orientation, if you just click there, you just get XY orientation, and that's looking a bit more like the curve that we know and love. Right, next thing, I'm going to change my axes around a little bit because things are going to start spinning around. So I'm going to go to edit axes and I'm just going to do the Y from -12 right up to 12, and that should give us all the room that we need to maneuver. Now I'm going to assume that your students are comfortable with doing all things to do with integration, and we've covered that in the previous few weeks. So what I'm going to do is I'm going to add a point to this curve. So I'm going to click on the curve to select it, and I'm going to add a coordinate, and I'm just going to give it an x value of 1. I'm not too bothered about the y value, and click OK. And it appears there. I'm going to do a similar thing, select my curve, and I'm going to pop one on with an x value of 3, click OK. And the start of this is exactly the same as how you do integration to find the area under a curve. You need to tell autograph that you'd like to do the area between that point and that point. So I'm holding down shift to select both points. I right click and down there is find area. Now we're going to use Simpson's rule again. It doesn't really matter about the number of divisions. I'm just going to pump it up to say number 10 and click OK, and there we go. Now this next bit could not be simpler. So if you, what I should say as well is if of course you want the numerical value of that area, if you've challenged your students to find it, if you just select it and if you just go down to, oh dearie me, there it is, view status box, then that'll keep a track of the area, and I think that comes out exactly to 12 2/3. Now to find the volume, dead easy. Make sure your little turtle's on, your little slow pot. Give your region a click, and if you right click, fingers crossed down there, you should have find volume. Now you get your options. You can choose your axis of rotation. Now we're going to look at that in the next couple of weeks, how we can spice things up a little bit, but I'm happy with that. Y equals 0, the x-axis. And of course, before you click anything, say to the students, what's it going to look like? What's the volume of that shape going to look like as we spin it around? Once they're happy, click OK and watch it appear. Now you can drag around the shape. You can have a good look if you have a spin round where it is. If you want to see that again, you just hit undo and you can repeat the process. And what I also like to do is if you hold down control and you click the left mouse button and push upwards, you zoom out, and if you pull down you zoom in, which is quite nice for getting a closer look at it. Now that's all well and good, but next week we're going to look at how we can use autograph to show where actually the formula for volume of revolution comes from, and then the following week we'll do some right dodgy areas with holes in them and all sorts. Hope that was useful. See you next week. Bye for now.